When considering ratios, we can use fractions to set up and solve for unknown values very easily. It's just crucial that we set up the ratio correctly to get the right answers. Let's look at this first situation. We've got a school that has a ratio of boys to girls that's 3 to 4. Now a class has 8 girls. How many boys would you expect to be in that class? Most people can look at this situation and easily see that it's going to be 6 boys in that class. But let's actually look at the situation and figure it out mathematically. You could do a trial and error method where we've got 1, 2, 3 boys, and then we do 1, 2, 3, 4 girls. Now over here I've doubled the amount of spaces, so now I have 1, 2, 3, 4 girls. So I'll do my 1, 2, 3 boys. And then I've got 1, 2, 3, 4 girls. And 1, 2, 3 boys. Now I've got 1, 2, 3, 4, 5, 6 boys. And I'm done. But this would get kind of tedious if we were using very big numbers. So let's look at mathematically. To write this as a fraction, it's very important we keep the same values on the same side of the fraction. So in this case, we're always going to have the boys in the numerator and the girls in the denominator. So I'm going to set up my fraction that I know first, which is 3 to 4. I know there's 3 boys for every 4 girls. But now I don't know how many boys there are to every 8 girls, but I can figure this out using math. So I'm going to do, my first step is actually going to be multiplying 3 times 8 and 4 times x. That's going to get rid of my fractions. So I've got 3 times 8 on one side and 4 times x. Now I can't actually multiply 4 times x. X is the value I'm trying to find. It's the number of boys in this class. What we can do though is to get rid of that 4 is divide. So we're doing is called cross multiplying and dividing. We can do 8 times 3 and get 24. Divide that by 4 and we get our 6. And that's our answer. This is a little bit more situational, that it's going to work if we have big numbers. This would work if we had little numbers and you wanted to kind of show it visually, but once the numbers get big, this way is a lot more practical. Now here's the steps. We're always going to use the same steps, just like we've done in the past. We're going to establish what values are going to be in the numerator, what will be in the denominator. We'll create our 2 fractions. Normally you're going to put the known values on the left and the unknown value on the right, but you can switch these two. It doesn't really matter. You're going to cross multiply and then divide, and that should give you your answer. Looking at these values, we're going to look at just some already set up ratios. And in some cases we're not even going to get whole numbers, but that's okay. Just follow the steps. So first we're going to cross multiply, so we'll have 4 times 9 and 3 times x. And then we're going to divide that 3 away. So 4 times 9 was 36, divided by 3 gives us 12. Now you're going to notice that I always am putting my variable on the left here. That's just personal preference. It doesn't actually matter which side you put it on. Here we've got 2 times y and 5 times 8. We get 40 divided by 2, and we get y equals 2. Next we've got 6a and equals 2 times 7. Then we get a equals 14 over 6, and we reduce that to 7 over 3. Looking at the next value, we've got 20z equals 5 times 3. That's going to be 15 over 20, or 3 over 4. Then we get 3m equals 2 times 2. M is going to be 4 divided by 3. And then finally, 2 times x equals 9 times 7. We get 63 over 2. Okay, again, these last ones didn't reduce, but that's okay. Let's look at some practical applications of this now. So we've got Steve has 7 yellow balls and 12 green balls. Assuming the ratio stays the same, how many green balls would Steve have if you now have 35 yellow balls? So we're going to set that up, yellow to green. Then we've set up our known ratio and our unknown ratio. We're going to cross multiply, divide, and get our answer. It's always important when we're actually answering a question to put some sort of therefore statement. So here we have there are 60 green balls. Okay, that's what we're actually trying to find. So we've stated it at the end. Okay. Here, we have Glenview Park Secondary School has 14 students for every one teacher. If there was a field trip with 11 teachers, how many students would be on the trip? So we've got students to teachers. 14 to 1 equals x over 11. We cross multiply, and dividing anything by 1 is just going to be whatever was on the other side. So we get, therefore, there are 154 students on this field trip. And finally, now Katie's out buying shoes and pants. Now she buys 5 pairs of shoes for every 3 pairs of pants she has. So we've got shoes and pants. We've got 5 over 3 is going to be x over 9 because she bought 9 pairs of pants. Now we cross multiply, we're going to do 5 times 9 and 3 times x. We get 45 over 3, we're going to get 15. So therefore she would have bought 15 pairs of shoes. Go ahead and try the questions associated with this note.